have so many classes. Dude, late start days are so nice, but are awful at the same time because they go so slow.
Okay, so we are back on the back of page 36 now, finishing up problem C at the top. So the job is to find the tangent and the cosecant, and we are given that the cosine is -3/5 and the tangent is positive. So cosine is -3/5 and the tangent is positive. We need to figure out where that's going to happen. Now, if you want to, you can go ahead and draw. If you want to, you can go ahead and draw your picture like, I can't remember who suggested this before, but it's a good idea. Go ahead and draw the picture, and there's an angle whose cosine is 3/5. But what's wrong with that?
Oh, that's a positive.
That's a positive, and it needs to be negative. Now, will the 5 ever be negative? No. So it's the 3 that needs to be negative, right?
Switch the axis.
So that means maybe I should draw it over here. Now, would that give me a -3/5 for my cosine? Yeah? All right, let's go ahead and find the other side then. So 3 squared plus x squared equals 5 squared.
Wait, this 4.
Huh?
That,
So that's going to be 4, right?
yeah, but 10 is bigger than 0. So would
Oh,
that have to be
yeah.
negative?
So he's saying, yeah, Mrs. Ford, that's all cool, but the problem says the tangent has to be positive. What would this tangent be? 4 over -3? So I don't think that's the right quadrant either.
Quadrant 3.
Quadrant 3. I'm hearing some 3s.
Wait, what happened?
What happened?
Wait,
We're
no.
moving quadrants. And I know this is 3, and this is 4, and this is 5, because that's the same triangle. And these are both negative in that quadrant.
It's got to be equal to 4.
Now, does this have a cosine that's -3/5?
Yeah.
Is the cosine -3/5?
Yeah.
That's good. What would the tangent be?
12.
4 divided by
Oh.
3,
I mean,
which is a positive number,
okay.
Yes.
right? So this quadrant is the right quadrant? It meets both requirements?
Yes.
This says the tangent has to be positive. So negative over negative would
Positive.
make positive. So now I got the right quadrant. Now look, kids, it took me a couple of tries to get there. That's okay. Just keep playing with it until you meet both qualifications. So the cosine is a -3/5 and the tangent is a positive number. All right? Now, let's answer the question. What is the tangent? These are the questions. What is the tangent?
Over adjacent.
Opposite over adjacent, so that would be 4/3. And what is the cosecant?
Opposite signs.
Reciprocal of sines. So hypotenuse over opposite.
5 over -4.
And there we go. Now, no question about it, those are tricky. Because what makes them tricky is you have to mess around with it. You don't always get it on your first try.
It's a puzzle, though.
It's a puzzle. That's exactly what it is. It's a puzzle. My guess is there's going to be one of those on the test, but we will, when we do our practice tests, we will definitely practice those. What we're going to do right now is what we've been waiting for, or at least I've been waiting for. We're going to do some sketching. Yes. Now, the good news is you are already comfortable with the basic curves, because when we studied the BFFs, remember? What do you know about sine?
Oh, that's the
That's the up and down one that goes through the
Origin.
original sin. Remember, origin sign. So when you drew these before, you did something like this, right? Now you also, when we drew them before, we went backwards, but you don't have to do that anymore. From now on, when you draw a sign, you're going to draw one hill and one valley. And that's it. Okay, yep. Now wait, before you start loving on me too much, we got a little labeling to do here. This is 1 and -1, and we labeled that before, right? Text, my friend.
Yes.
I am the important one right now,
Yes,
right?
ma'am.
Okay. So we're going to go up 1 and down 1. That's going to be our label. And then here comes the part you've never done before. This represents, this hill and valley, represents one trip around the circles that we were drawing earlier. So this represents 360 degrees because a circle is 360. So if the hill and the valley together make 360, what's this? 180. What's this? Wait, what would that be? 90. And this one would be 270. That is how you're going to graph your signs from now on. So you're going to label the top and the bottom. And on the main basic curve, those are ones. And you're going to label all these points, the top of the hill, the point where we cross, the bottom of the valley, and the point where we end. You're going to label those every time. Those are going to change. Those labels are going to change. We're going to talk about how to do that. But right now, I want this copied down in everybody's notes. And I want you to put a star next to it. And this is the basic curve. Okay? This is the starting point for every sign you ever draw in your whole life. That's what you start with.
So when you, this is like a question. So when you change 1 and -1, what is that? Like, what does that represent on that?
That would represent the amplitude of those waves. So it would be like turning up the volume on your radio.
Okay.
It would make the waves taller. And we'll talk about that in a minute. But first, let me get the cosine up here because I want to get the basic cosine up here too. So here's my basic cosine. That's the next one we're doing. Now, what about the cosine? What does it look like? Think back to your BFFs. What does it look like?
Same as that, but I think that's the origin.
Same thing, only it's up here like this.
Mm-hmm.
Now, when we drew them before, this is how we drew it, right?
All right, put that here.
But now we're not doing anything on this side anymore. So when you draw a cosine, it's going to look a little weird to you, but that's what it's going to look like. It starts at the top of the hill, it does its thing, and then ends at the top of the hill. Guess what these labels are here? 1 and -1.
We've done this kind of thing before.
We sure have. So what do you think all these labels are?
That first one's
90, 180, 270, 360. Aren't those the labels when you did the problems with the circle? Aren't those the labels of the angles as you went around the circle?
Yeah.
Yeah, same thing. We're just taking them off the circle and putting them on a coordinate axis system. All right, so that's your basic cosine.
Oh, I get it.
So you need, these two need to be ingrained in your brain because you will see, oh wait, we got tangent too, almost forgot. When we get to D, we're gonna modify this a little bit, but now we have the tangent. So, does everybody have these two in your notes? Good, okay. So now we're gonna do the tangent. The tangent looks completely different, and it was one of your BFFs, or not one of your BFFs, right? But it looks like one of your BFFs. I want you to put an asymptote here, and that's at -90.
Oh, yeah.
And you're going to put an asymptote here, and it's going to be at +90. I want you to put a dot at the origin, And then I want you to put in one of those squiggles that looks just like that between those two asymptotes. What does that remind you of? The cubing function. It looks just like the cubing function, except it has the asymptotes that contain it. The cubing function just keeps going. This is like confined between these two fences.
Why is it confined between 90 though?
Because if you looked at the values of the tangent on the circle, these are undefined.
Yep.
The tangent's undefined.
Oh, yeah, you're right.
So this is my tangent function, and this is our basic curve, okay? That's our basic tangent. All right, so now we're ready to look at a modified picture. So we're going to sketch 2 sine x. Everybody in the room, hopefully, knows that this is the sine picture. That's what I'm starting with. Now I got my basic curve, which is in your notes, and you know what all the labels are supposed to be, but as soon as you start sticking extra numbers into the problem, it's going to modify those labels somehow. So I want you to think back to all those weird shapes we drew. Who remembers what putting a 2 in front of the function did, Pat?
Multiplies height.
Multiplies the height. So see that 2 in front of the sign?
Yeah, the orange.
Guess what? It's going to take the original labels, which were 1 and -1, and it's going to multiply them by 2, so they're going to be 2 and -2. Did that 2 impact this at all?
No.
No. So this is still 90, 180, 270, 360. Now, if you'll notice your notes there, I haven't completely followed the directions. What have I not done? List the period and amplitude. Don't your directions say that? So we need to talk about period and amplitude. Very, very simply, period is your length horizontally. So when I look at this picture, it goes from 0 to 360, so my period is 360 degrees. Period is this way. So I still have my tangent up here. So I'll go ahead and put period and amplitude up here for him because I still have him. How far is it? Period is this distance right here. So I go from -90 to 90. So how far is that?
180.
180. So the period of the tangent is 180. So period refers to horizontal. Amplitude refers to vertical. But it's not the total distance, it's how tall the waves are. So for this curve, this one right here, the one I was graphing, the amplitude is 2. For your basic curves, the amplitude is 1. For your sine and cosine of the regular normal curve, A and B, the amplitude's 1. The period's still 360, but the amplitude's 1. Now, what about tangent?
Undefined.
Undefined. Does not exist. Tangent does not have amplitude, because if we define amplitude as a vertical distance, what do you see about tangent?
Just keeps going.
It keeps going. It's undefinable. You can't talk about amplitude. So tangents don't have amplitude, but sines and cosines obviously do. It's how high the hills are.
If you put it vertical.
or how deep the valleys are, one or the other. You can look at either one. All right, let's get another one done here. Maybe two more and then we'll be done. So y equals -3 cosine. Okay. Now again, my expectation is that you all know what a cosine looks like. So we know that a cosine looks like that. Now, if that bothers you, you can go ahead and sketch in the rest of it, you know, if that makes it make more sense to you. But I'm really just looking at this part right here. Who remembers what a negative out in front does?
Flips it over the y. No, it flips it over the y.
Negatives are flips. Negatives are, right? So a negative out in front is going to make you go upside down. Now wait a minute. What's that gonna look like? If I'm gonna go upside down, then that means instead of starting up here, I'm gonna start down here, right? And instead of coming down and making a valley, I'm going to come up and make a hill.
Yeah, the origin would be negative.
Right? Now, let's label these. I've taken care of the negative. It's upside down. What does this 3 do?
-3 and 3.
Multiplies the height. So this is going to be -3 and 3. Has this -3 impacted horizontal at all?
No.
No. So this is still going to be 90, 180, 270, 360. And I know as you begin drawing these, you're probably not going to have perfect shapes. But remember, the 90 and 270 are where we cross for the cosine. The 180 is the top of the hill or the bottom of the valley, depending on which way it's going. And then 360 is where you bottom out over here. What's the period of this picture? 360, beautiful. Period's this way, it's 360, 360 degrees. What's the amplitude of this picture? 3. Amplitude will never be negative because amplitude is a height. So I know that's a -3 out there, but all that negative does is tip me upside down, right? The amplitude is still positive. Okay, one more.
You throwing the x at it?
What is this one going to look like? Negative tangent.
Oh, it's instead of going like this, it's going to go like that.
So I know I'm going to have an asymptote at -90 and another asymptote at 90. Would you agree with that? Look at your basic shape.
Yes.
And what did we decide a negative out in front did? Upside down. So a normal tangent is like a normal cubing. It starts down here and goes up, right?
Just turns the line.
So this one's going to start up here and come down.
Yeah.
Yes.
What's my period?
180.
180. That's how far from -90 to 90. That's 180. What's my amplitude?
Undefined.
There isn't one. Yep. There isn't an amplitude. We are only going to sketch sine, cosine, and tangent, but just FYI, in case you're interested, this is the shape of a cotangent. That's what cotangents look like.
Because it's reciprocal.
We're not going to be sketching
That makes sense.
those. I know, you're sad. I know.
Whatever.